This video is about using derivatives to analyze graphs. So consider the graph of the function f at x equals sine x plus cos x. The first thing that we're going to do is find the x and y intercepts. So for the x-intercept, we're going to set y equal to 0. So we've got sine x plus cos x equals 0, which is going to give us a trig equation to solve. You can use your knowledge of the unit circle to solve this equation. If you don't remember the unit circle, you can find some information in chapter 13 in your textbook. And so your x-intercepts are 3 pi over 4 and 0, and 7 pi over 4 and 0. This information is going to allow us to sketch the function at the end. For the y-intercept, we're going to set x equal to 0. So we've got f at 0 equals sine 0 plus cos 0, which is going to give us 1. So that means that our y-intercept is 0, 1. Great. Let's go on to the next slide. And here, we're going to find the intervals on which f is increasing and decreasing and the relative extreme points. So here, we're going to use our first derivative. So that's the first thing that we have to do. Using our knowledge of trig derivatives, we get that f prime of x is equal to cos x minus sine x. The next thing that we need to do is find the critical points. So we're going to set f prime at x equal to 0 and solve another trig equation. So we get cos x minus sine x equals 0. Cos x equals sine x. This happens at x equals pi over 4 and 5 pi over 4. This gives us enough information to set up our sine table, because we want to know what the first derivative is doing on the left side of that first 0 point, in between the two 0 points, and then to the right of that 0 point. So picking our test values in those intervals, we can pick 0, pi, and 2 pi. And then we're going to check the sign of our first derivative at those values. So for our first one, we get f prime at 0. That will give you 1, which is greater than 0. So our first derivative is positive in that interval. At pi, we get minus 1, which is less than 0. So our first derivative is decreasing in that interval. Our last one is our first derivative evaluated at 2 pi, which is going to give us 1, which is greater than 0, which is increasing. That means that our first 0 point is a max, our second 0 point is a min. Once we've done our sine table, this is going to allow us to state our intervals, which is part of what the question is asking. So f at x is increasing on 0 to pi over 4 and from 5 pi over 4 to 2 pi. F at x is decreasing on the middle interval, so between pi over 4 and 5 pi over 4. So that also gives us more information to sketch our graph. Now the last thing that we need are the coordinates of the relative max and relative min. So here we're going to use our original function f to evaluate at our two 0 points. When you evaluate it at f at pi over 4, you should get root 2. When you evaluate the function at 5 pi over 4, you should get minus root 2. These answers are after rationalizing. So that means that we have our relative max at pi over 4 and root 2, and we have our relative min at 5 pi over 4 and minus root 2. Again, more information that will help us to sketch the function. The next thing that we're going to do is find the intervals of concavity. So when we're looking at concavity here, we need to take the second derivative. So f double prime at x is minus sine x minus cos x. And then to find our potential inflection points, we're going to set f double prime at x equal to 0 and solve exactly the same thing that we did for our first derivative. So this actually gives us the same equation that we solved for our x and y intercepts. So we've got x equals 3 pi over 4 and x equals 7 pi over 4. This gives us enough information to set up our sine table. We've got our 0 points. And then we're going to check a value in each of those intervals. So again, 0, pi, and 2 pi. Because we need to know the sign of the second derivative, because that helps to determine the concavity of the function. F double prime at 0 is -1, which is less than 0. F double prime at pi is equal to +1, which is greater than 0. And f double prime at 2 pi is again -1, which is less than 0. Once we have our sine table, now we can state our intervals. So our function is concave up when the second derivative is positive. That is in between 3 pi over 4 and 7 pi over 4. Our function is concave down when our second derivative is negative. So that is from 0 to 3 pi over 4 and 7 pi over 4 to 2 pi. Finally, we're going to find the coordinates of our inflection points. So just like we did for our max and min, we need the y value of our x coordinates that we found in step 2. So substituting back into our original function, f at 3 pi over 4, we already know sort of is going to give us 0 because it's an x-intercept. Same thing here, f at 7 pi over 4 also gives us 0. So that means our two inflection points are 3 pi over 4 and 0, and 7 pi over 4 and 0. The last thing that we're going to do is take all that information and put it onto a sketch. So let's start. We've got our y-axis and our x-axis here. We're going to label our x-axis in terms of pi's over 4, because that's what all our coordinates are in terms of. 3 pi over 4. 5 pi over 4. 3 pi. 7 pi. Using 4 when you're plotting just makes it a little bit easier. I'm going to shorten my x-axis there. I don't need that much space. Then I've got 1, 2, -1, minus 2x. Okay, so now my first point that I know is my x-intercept. I'm going to put that right here at 0, 1. I also know my y-intercepts at 3 pi over 4 and 7 pi over 4. The next thing I'm going to put on is my relative max at pi over 4 and root 2, somewhere around here. Pi over 4 and root 2. And then I'm going to put on my relative min at 5 pi over 4 and minus root 2. Then I can connect my dots. So I've got up, down, up. And then here my endpoint, I would have f at 2 pi equals 1. The homework questions for this one go with chapter 14, 14D.